This unit focuses on working with your data. It takes an example from a past class survey to show you some things you can do with your own data. The first thing you want to do when you get a look at your data set is run a frequency distribution of all the variables of interest to you. If you're using interval ratio level data, you would also want to run the descriptives. You would also want to run the basic descriptives. Take a moment to look at a general picture of the data. Take a moment to look at the variables. Do you notice any trends? Do you see any trends? Are there any categories that have a very few respondents in them? With very few respondents. You may need to collapse categories based on these results. You may need to collapse some categories. If you have interval ratio level data, do you have a few strongly disagree and to disagree? And lastly, can our data be compared to other data sets? You also could think about, can you compare our data set to other data sets to establish that we really do look like the region? One thing you can do to establish the reliability or validity of your data is to show that it looks a lot like the local region or the nation as a whole. In this case, I'm comparing the racial makeup of our sample to Los Angeles County, California, and the United States. In this particular example, you can see that our sample looks pretty much like the state of California for most ethnic groups, with a little bit too few Latinos. This is a nice addition to your paper. Here is an example of a pie chart that you might want to include in your final project. Even just taking a look at one variable at a time can tell us something about our sample. On this slide, I demonstrate that the median income group for our sample would hold the median income for the United States, California, or LA County. Again, it's just a good way to establish that our sample looks like the larger population. This slide shows the same example graphically, taking a look at the distribution for our sample compared to the distribution for the nation at that time. In this example, I'm going to hypothesize that there's a relationship between income and Facebook usage. The null hypothesis would be that there is no relationship between income and Facebook usage. In this hypothesis, income is the independent variable. How will I operationalize income? Well, I would have to operationalize it with questions on our survey. In this case, there is a question on our survey that corresponds to income. It's rounding to the nearest $1,000. Into what category does your pre-tax annual household income fall? Operationalization of the dependent variable, in this case Facebook usage, is a little bit more complex. On this particular survey, there were several questions that measured Facebook usage. One asked for categories over the last 24 hours. Another asked for how many hours a week. Another asked if they'd tried it, never, once or twice, with some regularity, or daily. And lastly, we asked people to enter the actual number of hours they spent per week using Facebook. Of course, we'd have to keep in mind that these are all self-reports. Really, if we wanted to measure this accurately, we'd have to ask someone to track their usage very carefully over a period. People may be wildly over or underestimating their usage. There's no way to account for that type of error. So the first thing I do is I take a look at the frequency distributions. When I take a look at Facebook usage for one day, I notice that there's very few people in the very, very heavy usage categories. It makes me think that maybe I need to combine my 7 through 8, 9 through 10, and 10 or more hour categories, since there's only 4 to 7 people in each of those categories. This is what the frequency distribution for Facebook usage over a week looks like. This slide shows the frequency distribution for Facebook usage measured in the have you ever used to more frequent usage. Finally, this slide shows the descriptives for the variable measured in the interval ratio level format. So what tests do I need to run for my hypothesis? What are my tests of significance and my measures of association? In order to determine this, first I have to ask myself, what is the level of measurement of each variable? Income is grouped into categories, so it's ordinal, but the categories are of equal width, so it could be treated as an interval ratio level variable in theory. Facebook usage is measured in both ordinal, nominal, and interval ratio level formats above. So when you're getting ready to run your tests, think about what is the level of measurement of the variables in the form in which I'm using them. Don't forget, if you recode, you might have changed the level of measurement. Always use the form that you're currently using, not a previous form of the variable. Don't forget, if there were very few people in some categories, you're going to want to collapse those categories into fewer. If you have less than 10 respondents in any nominal or ordinal variables categories, you don't have enough people in there for the test to work properly. Hence, in order for me to look at Facebook use in the daily form, I recode it, eliminating the higher use categories or collapsing them into 7 or more hours. I also recoded Facebook usage ever, as some of the categories had very few respondents in them. Next, I run my test. Here's the crosstab of Facebook usage in 24 hours by income. In this case, I have two ordinal level variables. So my test of significance to determine if there is or is not a relationship is chi-squared. Looking in the asimp sig column, I see that chi-squared's p-value is 0.034. The actual value of chi-square is 48.032 with 32 degrees of freedom. P equals 0.034. It is less than 0.05. I can reject the null. This tells me that there is a relationship, but it doesn't tell me how strong it is. For that, I take a look at my measure of association. With two ordinal level variables, it's gamma. The value of gamma is negative 0.209. Worth noting, it tells me that as income goes up, Facebook usage goes down. This crosstab looks at income by hours per week on Facebook. Again, I have two ordinal level variables, so chi-squared is my test of significance and gamma is my measure of association. In this case, the value of chi-squared is 44.739 with 32 degrees of freedom. P equals 0.067. Very close, but I cannot reject the null at the 0.05 level. However, I'd still probably say there's some evidence of a relationship. Also note that gamma is negative 0.122. Weak, but definitely worth noting. I would say with a larger sample size, we probably would achieve statistical significance. Chi-squared is affected by sample size. If you don't have a large enough sample, even if there's a relationship, you may not be able to reject the null. This table looks at income by Facebook usage measured as never tried all the way up to daily. Again, I'd be using chi-squared as my test of significance. In this case, chi-squared is 38.629 with 32 degrees of freedom. P equals 0.195. I cannot reject the null. However, when I look at the measures of association, and in this case, I think I would use Kramer's V because I think the way that we measured it is more nominal than ordinal, I'd still see a 0.153. There may still be something going on here. Maybe the way we asked the question was a problem. Now, when you find a relationship, one thing you can do is what we call elaborate. Take a closer look at that relationship. I have to ask myself, is gender playing a role with income and Facebook usage? I can add a layer by gender, something I'll show you how to do in lab. This giant table breaks income and Facebook usage into two components, one for male and one for female. Unfortunately, we didn't have enough transgendered individuals in our sample to include them in this test. Now, when you add a layer, you get a test of significance for each layer as well as a measure of association for each. So what these results of these tests are showing me is chi-squared just for men and the effect that income has on Facebook usage, and then just for women, the effect that income has on Facebook usage. Take a look at what happened here. It's statistically significant for men, P equals 0.001. However, for women, P equals 0.431. There's a statistically significant relationship between income and Facebook usage for men, but not for women. Taking a look at the strength of the relationship, we see it's negative 0.451 for men. A moderate to strong relationship. Here I've added the layer by gender in the weak format measurement of income by Facebook usage. Will the relationship still hold? Again, I find a statistically significant relationship for men but not women. For men, P equals 0.042, but for women, 0.147. The strength for men is negative 0.289, whereas for women, it's negative 0.083. But it wasn't a statistically significant relationship for women. To test the difference between Facebook usage by income in the interval ratio level format, first I tried dividing income into just two categories, $70,000 or less and over $70,000. Why? Because for this region, that's about where they estimate you need to be comfortable. Was there a statistically significant difference measured in this form? Well, I performed a difference between means or t-test. As you can see in the resulting table, no, there was not a statistically significant difference when measured in this way. I decided to try to see if I could test it using ANOVA with more income categories. First, I took a look at Levine's statistic, and as I can see, for Levine, since the significance is 0.658, I can use ANOVA. The variance between the categories is not problematic. If you take a look at the results of my ANOVA, however, we don't find a statistically significant relationship in this case. P equals 0.744. I cannot reject the null. Next, I'm going to hypothesize that there's a correlation between self-esteem and Facebook usage. In this example, the null is that there is no correlation between self-esteem and Facebook usage. To measure self-esteem, you can't just ask someone about their self-esteem. Instead, we're using some items from the Rosenberg self-esteem scale listed here. As you can notice, on some of these items, the higher the score, the higher your self-esteem. But on others, the lower the score, the higher your self-esteem. You just want to make sure that you recode some of the ones that don't run the same as the others so that each item's response categories are running the same direction. So to ensure that all the items in your scale run the same direction, make a decision. Is the higher the score, the higher the self-esteem, or the lower the score, the higher the self-esteem? If it's the higher the score, the higher the self-esteem, for any item where strongly agree actually meant lower self-esteem, you need to reverse recode it, such that the value of category 1 becomes 5, 2 becomes 4, the neutral category 3 stays as 3, 4 becomes 2, and 5 becomes 1. Remember, just because you told the computer 1 becomes 5, it doesn't know that 5 becomes 1. A confirmatory factor analysis tells me how many different components are made up by my index. I won't test you on this, but I just want you to know that there are statistical tests that allow you to analyze if your scale is working properly. In this case, it absolutely is. Another thing you could do is calculate the reliability of your scale using Chronbach's alpha, as we've discussed previously. In this case, I'm going to construct a complex index. I'm going to add each of the items in my scale, and the recoded items if necessary, together. The minimum possible score on my scale would represent the total number of items being combined. The maximum score on my scale would be that number multiplied by the number of data points for each item. So let's take a look at my self-esteem index. There were 5 items going into the index, so the minimum score is 5. On this scale, the higher the score, the lower your self-esteem. So the people scoring the 5 had very high self-esteems. Because there were 5 items and 5 points on each particular item, the maximum score is 25. We can see that very few people fell into the very low self-esteem end of the scale. If I don't want to work with this as interval ratio level data, I can recode it into an ordinal variable of high, medium, and low self-esteem. Here's what it looks like with the ordinal recode. As you can see, it does appear like we're going to find a relationship. What do you think? Indeed, when we take a look at Pearson's chi-squared, it's got a value of 26.495 with 8 degrees of freedom, p equals 0.001. We can reject the null. There is a statistically significant relationship. Gamma is 0.115, weak but worth noting. The more you use Facebook, the lower your self-esteem. Even though gamma is positive in this case, remember, in our scale, the higher your score, the lower your self-esteem. Finally, here's an example using Pearson's R. In this case, I'm hypothesizing that there's a statistically significant relationship between texting and self-esteem, and also between self-esteem and visiting online sites. In each of these cases, I measured these things as interval ratio level data, or I used my self-esteem index in the original form. As we can see, there is a statistically significant relationship between self-esteem and texting. P equals 0.003, and Pearson's R is 0.146. Weak, but worth noting. The more you text, the lower your self-esteem. We also see that there's a statistically significant relationship between self-esteem and visiting online social networking sites. P equals 0.000. Pearson's R equals 0.192. Weak, but worth noting. And interestingly, there is a statistically significant relationship between texting and visiting online social networking sites. Though I suppose that's not surprising. High technology use in one area is likely to predict high technology use in another. In this case, P equals 0.000 and Pearson's R is 0.516. So, just to review, once you've used the data to create frequency distributions, crosstabs or descriptives, your tests of significance and measures of association, and the appropriate graphs and charts, then is there anything else? Don't quit yet. There's one more very important thing you need to do. What are the implications of your findings? What's the context? Income and access to the internet? Is that a social justice issue? Self-esteem and usage relates to consumerism and advertising. That's an important issue too. Cite the literature to explain and provide context for your findings.